Chat appearance, pop-up message. Hey Jams, how you doing? I don't know if it's Spanish or English, but what's up? There you go. You get a wave. Let's get this going. Let's put some music. Hi Spanish, come to learn Golang. Ah, ok, perfecto. Voy a estar haciendo un mix de inglés y español. Maybe I may do more English. Pero si tienes preguntas en español, igual también con confianza. Hay un experimento mío extraño de hacer el stream con ambos idiomas. Okay, so de hecho este lo grabé. I recorded this today, so going change. Okay, done. True. Okay, so esto ya lo puedo borrar. Okay, so what are we gonna do today? Well, this is not gonna be like a long stream, but what I want to do is do a little bit of Leetcode, and I actually have to study for a Golang exam. So I just want to get one or two questions done at least, hopefully more. I may do really bad, you know, so hopefully I'm not embarrassing myself. I was doing linked list the other day, and I was doing so merge to sorted lists. I already did this. I don't know if I have reverse linked list done. I think I do. Let's see how that looks, because I know that my code with the zoom that I had before, you could barely see it, so maybe that is better. Let's see. It's still a little bit small, but I don't know. People in Twitch, is there anyone in Twitch? There's one viewer, so hey, you viewer on Twitch. What do you think about Zoom? Is the font good? So let me show you the font. People on YouTube, what do you think about the Zoom? Like, is the font size good enough, or you know, if not, I can zoom more. Jams, cualquier cosa dime si ves que la letra está muy pequeña. Si no, pues seguimos. So I have a bunch of solutions here. You know, I've done this. I've done Leetcode before. So if I go to link lists, reorder, yeah, I have reverse linked list. So I don't want to open that file because I don't want to see the solution. So I'm just going to put working.go. This is a simple one. I like to do simple ones to warm up. And even doing simple ones, I may get like the wrong answer. The thing is that, so the reverse linked list and merge two sorted lists are very similar in order to solve reverse nodes in K group. So just to show you guys, what is this doing essentially? So you have 1, 2, 3, 4, 5, K equals 2. Given the linked list, reverse the nodes case at a time. Actually, no, this was not the one that I was seeing. Actually, was reorder list. I think it was this one. This one, there you go. So this one, in order to reorder the list, you need to be able to point nodes in the direction that you wish. And so, for example, you have 1, 2, 3, 4, and then you have 1, 4, 2, 3. So essentially, you know, this like the desired output. So you have like the first and the last. So first, last, then second, first, then second, last, second, first, second, last. So that's how the problem should be done. So here, 1, 2, 3, 4, 5. You should see 1, 5. I thought it was 2, 3. Oh no, sorry. 1, 5, 2, 4, and then 3. So essentially, you go like through edges towards the center. So that's the gist, essentially. One, 5, 2, 4, 1, 4, 2, 3, 1, 5, 2, 4. Yeah. That's the gist. You go from the edges, and then you move inwards. So that's the problem. But so I don't want to do this right now. I'm gonna, you know, this is very simple. I've done this a million times. Oh shit! I saw the answer. I didn't know I had it saved. All right. Well, damn it. I thought I erased it. Well, by memory. I don't know. Here goes nothing. You need like a nil, like previous is equal to nil, and then for head, like 4 would be just like a normal while loop. So while the head does not equal nil, you just go ahead and keep on going with a while loop. You remember again that in Golang there's no while loop, so you just write 4. And then this would run forever if head is never equal to nil, but in this case it will. And essentially, what you want to do is create inside of the loop a temporary variable that will point not to head, but to head.next. Then, in order to reverse a linked list, essentially, I'll do this in Excalibur, why not? Probably you guys saw this from today's video, maybe not, I don't know. Let's delete this. Alright, by the way, I should probably put this on YouTube. I mean on YouTube, put it on Twitter that I'm streaming. One sec. All right. And one more thing, let me just, I wanted to check something about the song. Add to collection. All right, sorry. Okay, so what do we have? We have a linked list, and let's say I'm gonna do something simple. It's 1, 2, 3, 4, 5, and we reverse it to 5, 4, 3, 2, 1. Very simple. We have 1, 2, 3, 4, 5. So essentially what we need to do is change the direction of the arrows. I know, so simple, huh? There is a trick though on how to do that. How do we reverse the arrows? And the trick is the following. You need like a temporary variable that kind of like when you do sorting. I don't know if you guys have done sorting before where you have to create like a temporary variable to place in like the values that you're going to swap. So kind of something similar you do when you, because you're essentially swapping, but you know, you're swapping pointers rather than values. And you know, first you point like the first value to nil, right? This is going to be nil. So yeah, essentially that's how you change the arrows. That's not what I was looking for. Okay, whatever. There you go. So yeah, let's go ahead and do that. I know, I mean, I saw the answer, so it's not cheating. It's just I don't remember I had it there. I may even get it wrong the first attempt, but let's see. So head. So remember the head right now is 1 in this case. So what we want to do is head.next pointed to previous, which in this case previous is nil, right? So now we're saying that the 1 is going to be pointing nothing because it would be the last. So this one will point at nothing. Then we want to make sure that head.next is equal to, no, not sorry, head.next, head. So right now the head is pointing to 1, or head is 1. So what we need to do now is head equal to temporary. No, actually, sorry. Previous must equal head because head would be 1. So now previous will be 1. And then the current or head.next or head, sorry, will be equal to temporary, which will be 2. Why are we doing this? Because then temp.next, the next round would become 3. We say that head.next is pointing to 1, and then that previous would become now 2, and then head would now be 3. So essentially we're just changing the pointers. And we return head, no, previous. If we iterate through all at some point, yeah, we should return head. Let's try this. I may get, there you go. Let's see what's my error. Chart 13, use of untyped nil in assignment. Say like a list node, like a look at that. This is the only thing that I may get like thrown off. Output expected. Ah, okay. Head output. Okay, so it is working. Why? Because we have 0. Do I have to put? So see how like value. Default value is 0, so I guess that val is equal to 0. I mean nil. Jesus. Okay, I need to Golang point to nil list node. So I don't want to look at my answer first. I really want to try before I look at my answer. Yeah, that's a struct insert. Yeah. Duh. Okay, maybe it's that. Where is this? Okay, so let's go to 9. So preview var. I wish that I could put my personal key bindings here. Var previous list node. Let's try that. Is that precompiled? Ah, okay. Because there's like a nil pointer. Okay. Well, there you go. Even by looking at the answer, I had it wrong at the first time. Okay, so and this is an easy one. Jesus. Okay, so that's done. Damn, I don't want to do the other one. Not right now. But I'm gonna delete this and reverse linked list. Oh, look at that. So I set up both temp. Nah. Alright. That's fine. Okay. What do I want to do? Data JSON reverse. Done, true, okay. Okay, so make run exclude equals true, because I want to exclude everything that is not within the Leetcode 75. Invert flip binary tree. That's not a bad one. I think this is an easy one. I may be wrong. Okay. What was I doing? Oh, sorry, got spaced out. I was putting something on Twitch. Okay, what was it? Trees. And it was invert. I think it's this one. It's also an easy one, so why not? And I haven't done trees in a while. I didn't want to see it. Okay. Let's see. Invert. Yeah, I have it. We'll leave that then for another time. Do they have sets in Go yet? I I don't think they do. It's just, I would just use maps, honestly. Is there a hash set in Golang? So the only way to use a hash set is to use map t struct. That's a weird one. It's fine. It's fine. A bit ugly. So I decided to write my own hash set implementation. It's a hash set implemented based in open addressing algorithm hopscotch. Okay, this guy. Map string struct. Ah, that's a weird one. Let's see if there's like an official how to create a hash set in Golang. I mean, I would just create a hash map with a Boolean value. I don't know. Yeah, see, like map in Boolean. I would just do that. Oh, hash set. There you go. So type set, string size contains clear. Interesting. So there is, apparently. Hash at go. Set Neil. The whole, yeah, so like they under the hood, I guess it's like imperial. Yeah, kind of like the example that we saw before. Open source insights. Okay, package size implement set by a hash table. Structure is not thread safe. References. Yeah. So there you go, Alan. But yeah, I would just. But it's not part of the standard lib. I don't think so. It seems to be like a outside implementation. Yeah, it's not part of the standard library. What did I see that was part of the heap? Like a heap or a heaps in Golang. That now is not in Python. Heap in Golang. That is part of the standard library. So I like that. So yeah. Since like useful to say when doing Leetcode. It is like a set is useful. A heap I think is more useful. I'm definitely grateful that you have this. It's a little bit funky the way you have to implement it, but it works. For a set, I would just use a hash map. Well, yeah, a hash map, and just put like a boolean and call it a day. Definitely you have. I guess you have more memory allocated with a hash map. Depends on how you set it, but I wouldn't be too worried about that. Just create a hash map with a boolean value, with a boolean, whatever you want to store, and then the value type of boolean. That's what I would do. Given the root of a binary tree, invert the tree and return its root. We said that we were gonna hold on this. Probably already forgot, even though I saw the answer. So I'll do it in a bit. Word search. Ooh, I know that's like a hard one. Word search. Leetcode. Graphs. It's not that I hate graphs, but I'm so rusty. Okay. I'll leave this open. I'll do one more. Letter combinations of phone number. I remember that not being too bad. combinations of phone number. Damn. Okay, one more. Decode ways. Damn. Decode ways hard. Decode ways, Leetcode. Or medium? Okay. Reverse notes in K group. Okay, I already have too many open. Kid largest element in an array. All right. I'll close the code ways. I'll give it a go. You know, I have to do some medium either way. So I have these two mediums. And I saw them before, so I should somewhat know what to do. So which one I think I'll fail the least? Probably this one. Let's read the problem. So I know for a fact this is a graph. Looks like a specific path. So I know for a fact that this is initially at least is DFS, so depth first search. So whenever I try to not memorize but to reason which graph algorithm to do, DFS you look for depth, so you make sure that whatever the path you're looking for is solvable or such path exists. Otherwise, you know, there's no such path. And breadth for search, you look for like multiple paths, so like shortest path or, you know, more efficient route, whatever. So in this case, the algorithm that I would probably look into would be DFS right away, but I haven't even read it, so let's see. Given an MX grid of characters in the board and a string word, return true if the word exists in the grid. Yeah, so this is DFS right away. I just want to make sure that whether it exists or it doesn't matter like how you get there. So DFS for sure. The word can be constructed from letters of sequentially adjacent cells, where the adjacent cells are horizontal or vertically near neighboring. The same letter cell may not be used more than once. Okay, so you know DFS use it for possible path, and DFS we need to use a queue. No, sorry, not a queue. We use a stack. Sorry. For BFS we use a queue. For this we use a stack. Okay, so we have that. I'll attempt this. I'm curious if I've solved it. I don't want to see, but let's do this so that way I don't see the answer. Graphs? Nope. Binary search? No. Graphs. Course schedule. Oh, that's the only one. Okay, so I haven't done it. So probably I'll work on Vim instead because it's more comfortable. What was it? Word search. Word search. Then go. Package graphs, and then let's grab the function here. I'll make this a little bit bigger so you guys can see. Okay. Okay. I mean, I have to start at a point. So normally, like, to start at a point, you need a double for loop to, you know, choose X and Y value or row and column value. My guess is like, so the board you have whichever letters you have, but then you have the word. So first you point to A. If at some point you find A, then you move your pointer to B. Then from where you are at, then you look for the adjacent neighbors whether the bee is within reach, and you keep, you know, if you find it, you move to that bee box, and then within the neighbors you try to find the next letter, then within the neighbors you try to find the next letter, within the neighbors trying to find the next letter, and so on and so forth. If you go through all the letters and you find the boxes, then true. Otherwise, if at some point there's no neighbor, which is only adjacent, meaning not diagonal, then you return false. So I guess letter index is equal to word 1. Wait, can you? I always forgetting Golang. Golang playground. Probably I should just test it in my main. What am I doing? I think I can, but I don't know. Sometimes I think some languages don't allow you to do the following. Maybe I'm tripping. Ah, see? How did I print runes? I know runes are like bytes. Seems like useful this. Oh, sorry, I already read that. Hey, Twitch community, you are very quiet. How you guys are doing? Any questions? Any mentions, observations, anything of the sort? And test Arturo. How did I? All right, so we already said that print, and I should know this by now. Just run, damn it. 118, which is probably the ASCII. How to print the character of a string in Golang. Yeah, I don't care about my typos. Let's go Bard. Yeah, I don't. Okay, that's not what I was looking for. Printf. No, that's not what I'm looking for. String formatting. No. All right. I guess this still, unless I want to print the character itself, I guess like under the hood this knows that like it's going for the R. If I want to print the character itself, I guess that I would do printf and then do you know, percentage %C, which stands for character, and there you go, there's the R. Okay, but under the hood it's the same thing. Okay, just wanted to make sure what I was writing. Letter index is equal to word. Hey Charles, how you doing? Where are you watching this stream from? I don't know, any doubts about Golang, any observations, mentions, and anything you want to put, go for it. So letter index is 0, sorry, not the character itself, because we'll increment this and we'll refer to word in a bit. So for I'm just gonna do a normal for loop just for this ease of use. As long as I is less than length of word, I plus plus. So for j is equal to 0 as long as j is less than, and I know this is a double for loop, so board 0, because it's just accounting for like the single row length. Single row length. And then j would be len board I j. And then j plus plus. Okay, we'll deal with that in a bit. So the argument board variable type byte for length. What's the question? Hey Sid, what's up? So the question that we're doing is this one, not that one. Let me close this, this one, word search. From Brazil, hey, nice. Really want to go to Brazil at some point in my life. Heard good stuff about Brazil. So Sid, the question that we're doing is this one. Essentially, we have to do a DFS, make sure that there is a possible path of words within the board. So that's what we're doing at the moment. Let me make this a little bit narrower so we can see the chat. There you go. Missing return, yeah, that's fine. For now, so this doesn't complain, I'll just put return false. Actually, return true, and then the false will be within this, whatever. Variable type byte. How to access values of 2D arrays in Golang. Well, 2D slice, but same difference. Not of integer, like it's okay, not useful. Valid board variable of type byte for len. No suggestions. I mean, I know that I'm, so here I have an array of bytes, so an array of characters. So now this is fine, but this is not fine. Access value in matrix of battery colon. That's exactly what I have. Then why is it not? Okay, let's test this because am I missing something? Alright, let's just try to print the 5, so that would be row 1, column 1. Aha. Okay, so we have the same thing. Okay. At least I'm not going crazy. Valid matrix of type. Okay, so... Oh, duh, you cannot get the length of that. I'm sorry, yeah. That does not make sense. Because you're getting a single value. My bad. Brain fart. Brain fart of mine. Is it? No. Okay, so let's do this. So essentially, like, this one length. So for each row, why am I brain farting so bad? Like I should be able to. I mean, I know that I need a double for loop to access values. I'm gonna try this way before. It's, as you can see, I'm rusty, so bear with me. Don't know what that means, but Innocent Ganu, what's up? Super Chat Donga, si llega, hacking, by Facebook hacking si llega. Okay. All right. And then matrix. Okay, so this is wrong. What? Oh, duh. My bad. Okay. I don't know. I just want to try that for the sake of having at least something without looking at the answers, of course. Okay, so 1, 2, 3, 5, 4, 6, 7, 8, 9. Okay, so that's it. Okay, so I'm not that lost yet. Okay. Spectra brand. Oh, Len. Okay. Alright, so now I can delete this. Okay, so now we know we are accessing each part of the board, and I can do the following just to see something printed, if anything. So what did I do? I did format dot print, and I did board I j. Then here format print line. Then here I can call up my, what is it? Graphs dot, okay, let's make this, and I know I'm taking my sweet time on an interview. I probably wouldn't be able to take this long. Board is equal to a double array of bytes. Hello. Hello, you tube. Okay, board declared not used. Okay, so there's my board. And the word, let's say, well, it has to be of the same, 1, 2, 3. It has to be of the same length, so let's put like something random. Use. A little bit Liverpool from there. And let's say that we want to find, I don't know, USB, whatever, word USB with, okay, there you go. So it exists. I'm gonna pass my board, I'm gonna pass my word, and I want to make sure that USB is within this, that it is. It's this, this, and that. Make run. So we want to bring the character, so I'm gonna do that. Hello, use tube. Okay, there you go. So we're getting somewhere. I don't know. I like to have this like in a graphical way. I know, some people don't care about it. I like having that, so I'll do that. So now I can go ahead and uncomment this. So the letter index, or probably it's not, well, char index is pointing to the first one. So if board ij is equal to word char index, then do a DFS. Run DFS. And DFS. Well, definitely we need access to the board. We need access to the X and Y coordinates, which is I for X and Y for, and J for Y. These are ints. And by the way, you can do this in Golang where, the board is actually of type a 2D array or a 2D slice of bytes. But since I and J are both integers, you can just like group them like that, which I think is cool. And then DFS. Essentially, we're going to be doing our recursion. I'm trying to think, because if we find the first one, we want to find obviously the neighbor. So essentially what I would do is the following. I can do the DFS, a function that returns a boolean. So at the time that we find the first one, find near, so yeah, the DFS, like I'm gonna do the DFS for that. So essentially the DFS will find the nearest cell. So but the thing is that, in this example, in my example, say USB, so I'm gonna go through all of the matrix or the 2D or the graph, whatever, until I find the first one, which is U. So I'm gonna say, okay, U, look for the neighbor. T, okay, no. O, no. Well, in this U wouldn't work. This U would work though. So you look for the neighbor to the left, no. Upwards, no. Downwards, no. Rightwards, yes. Then enter another DFS within the DFS. So this would be like a stack. So now we're in the second second recursion of the DFS. So same thing, left, no, up, no, down, yes. And then we will always have to check whether we've gone through the whole word also. So definitely it would be sensible to put the index Yeah, so the pass cell, we'll do the checks inside of the DFS, but definitely yes, that is a good point. We want to make sure that we don't go past. So for example, if we're in U, like we cannot check downwards. The index is like if we've already gone through all the indexes, then we don't need to. We don't need to keep on checking. Which I don't know if I know this is not the right way of doing it. Or not that is not the right way, but I'm passing too many parameters. I'll clean it up later. But I'll leave that there for the moment. Let's give ourselves some time. So it's 11:40 where I'm at. Let's give ourselves 25 minutes from now. If in 25 we don't find it, then I'll give it a rest. Focus. Let's give ourselves settings. 25. All right. So what am I doing? So I'm gonna be passing a current index, right? The word will always stay the same. So if what is our like when do we solve the problem where board ij is equal to word index. If so, we return true. Otherwise, then we do our DFS. No, actually no. We want to do if. No, that's not the right result, because we found here that it matches. So what we want to do is that. Yeah, this is not the like final resolution. What we want to do is if index, so if we're at index, if we're at the last index, it means that we found the word, so the whole word path. So if index is equal to length of word -1, right, because we started at 0, then return true. I think so. All right. So let's say that we are U. We want to make sure that we can find B. So how do we find B? So first we want to check that there's no upper bound, so that we're not going past the upper bound, lower bound, right bound, left bound. So if we go if we are within those bounds, then DFS, and then what we want to do is keep on checking. We would pass the board. So it would be I -1, because I -1 is just going upwards. J would stay the same, and we would pass a string. And this would be if upper bound, if J is less than or equal than 0. I think so. I'll format this a little bit nicer. I know that I'm trying to like put one-liners, and that's not idiomatic in Golang. So there you go. Lower bound. If sorry, and this is Y. I mean, sorry, I, not J. If I is less than length of board, then DFS board I+1 I J string. Oh, I'm not missing word. What does that say? Mixed named and unnamed parameters. J. All right, I'll check this in a bit. Anyway, right bound. What's the right bound? So if J is, well, actually I want to do let's do left bound first, then we do right bound. So the right bound would be that J is less than or equal to 0. So then we can do DFS board. Sorry. Yeah. as long as j is bigger than or equal to 0, then we can keep subtracting to j. That's the the thinking behind it. What am I doing? String? It's word. Okay, I'm still getting an error here. Oh, the index, that's why. IDX. Well, okay, I'll do a check right now, but if the index is correct, then we'll have to increase the index. But I'll do that right now. So, and then as long as j is less than land board 0, return DFS board I j plus 1 IDX word. I mean, I'm missing something crucial. Like, yeah, we're traveling through the whole thing, but how do we know when we find a match? Because when we find a match, we want to increase. So well, if we find a match, then I guess we can automatically do I++, right? Because like at this point we found a match, so then we just increase that and fire this. But oh no, we need to make sure that there's a match. So if word IDX is equal to word IJ, then we can increase, and then we do the IDX XX. And then in the recursions, you know, if the current word, you know, is matching, then we do this. Otherwise, we don't do that. And then return true, I guess. Otherwise, return false. Or if that is not equal to that, then we return false and we don't even have to do anything. And then if we get past that, then we can do that and then return true. I don't know. I may be doing this in a very unnecessary way. And bad way. I don't know. Okay, let me get rid of this thing so you guys can have more view of this. Okay, mix name and parameters. Why am I still getting that error? IJ IDX subtype int. Okay, I don't know why. Board byte. Alright, whatever. Mix numbers and the name parameters. Okay, whatever. What was it? Word. What? Oh, I have the two. I'm thinking of TypeScript too much. Jesus, man. That's why. What the? Okay, invalid operation cannot index word I. Bored. You guys probably got that before I did. And then DFS. Board IJ IDX word. I can honestly pass 0. It's the same thing. I could probably get rid of this. So I have to make it global. Just get rid of the formatting there. Library. I don't need it right now. Watch this crash. Okay, let's go ahead and copy this. Okay, and then okay. What? Index out of range. Okay, sweet. Means probably my recursion is wrong. Okay. And that's why I have this here. Well, so I know that this is gonna give me an error. I just want to see it printed. Actually, let's print the character. What? Oh, okay. ULTSU and then the panic. That's funny. I was like, what is going on? But it is printed. There you go. So UT, so it's going upwards, right? So that's one part of the recursion. Probably I should check that, like, if the word doesn't match, just return false. Oh, I do have that, but the print is before that. I don't know, I just want to see, I'm curious. It shouldn't print, it should print less. There you go. So US, there you have U again. Or US, and then it's going left again. So we have to make sure that that doesn't happen again. And then index out of range 4 with length 3. How do we... So the thing that I can do is the following. Make like, not erase, but like check that that hasn't been visited. So for example, if said, you know, that we're not passing the limit, and then where we are going, which is board I -1, so it reduces the amount of recursions. Board I -1 j is equal to word idx. Damn it, JavaScript. I blame you, JavaScript. I'm kidding. I love JavaScript, by the way. I have nothing against JavaScript. Okay, and then this is +1. So obviously all of this won't be fired unless one matches. Okay. Then the last one. And I missed the end. Okay. And then, okay, so now we have to change this. The I remains unchanged. Here we're subtracting, and then here we are adding to the J. Because we're going, what we're trying to do is, you know, here we're going upwards, right? So I -1, you're going upwards. So say that you're in the U, you're checking every way up. Here, I +1 is downward, so you're going down. J -1, you're going right, so J going right is like that. And then J +1, sorry, J -1, you're going left. J +1, you're going right, which probably I should change that. I think that will cause an error. J -1, you're going left, so no, that's right. Yeah, that's right. J+1, you're going right. Yeah, so I had it right. I don't know. I don't know if I was tripping. Is rating with a party of 2. Yeah. What's up, Mr. Valdez? Well, at some point we had 2 viewers, so it would have been nice that the other viewer remained. But we're 2 again. Hey, what's up, man? Trying to solve a graph problem. It's a little bit stuck in this, but we are getting there. Okay. So, te quedamos con toda la fiesta de 2 personas. Eso es todo. Hey, Kiwi Sea Guy. Hello, how are you doing, man? So that you 2 guys were at Mr. Valdez stream, probably doing some DevOps, some Kubernetes. Damn it. Okay. So just Miguel and Kiwik to give you some insight of what I'm trying to do is to solve this Leetcode problem. The problem is word search. So right away I can see that this is path finding, and path finding normally defaults to DFS. So what I'm trying to do is, first of all, I'm doing a for loop. So I'm doing a for loop to access the values of the board. Whenever I find the first word, which in this case would be U, if the word is USB. So if I find U here, then I try to find the nearest neighbors, like adjacently, so not diagonally. And if I can essentially, see the next word, in this case would be S, then I keep on going until I find, until the index where I'm at is equal to the length of the word, which in this case index would be 2. The length of the word is 3, but length worth minus 1 is 2. So then I just return true and exit the recursion. And then I just assign that to res. Which should return true all the time. I don't know if that's like the correct way of doing it. Probably I'm tripping somewhere here. But then, if all goes well, everything is true. Otherwise, at some point, there's a false value. Actually, no. Yeah. Well, yeah, this is probably wrong. So I gotta get rid of that. Or I can do the following. No, I need to return something. I have to have a false at some point, but then like, when do I know that there's a no successful? Time ran out. All right, so I'm really rusty. And by the way, the guys that raid the party haven't seen me doing this, but I've been doing this like for 40 minutes already. So actually, I'll see a hint. Let's try a hint before I try to see because I previously have solved this before, but I don't want to look at the solution. Yeah. Also, so I have USU. So what's happening here? USU. So I'm having U, it's going to the right neighbor. Then I have you know, I'm going left again. I shouldn't be doing this. If I put my checks here, so I don't know why it's still printing the U for the second time. Yeah. Okay, let's look for a hint. Description. I mean, well, essentially, if I go through all of this and this never happens, then I return false. So I guess that all the way here I return false, and then up here I return nah. I don't know. Yeah, I don't know. I mean, ideally there should be a combination of. Let's look for a hint, and then I'll reword my thinking. Topics, hints. I remember there were hints. Discussion, no. I don't want to see discussion, no. Similar questions. This may give me a hint. Word search. Oof. No, I don't want to do that. Alright, I'm gonna give myself 10 more minutes. If in 10 more minutes I cannot like figure something out, then I'll just look at the solution, because I would be going in circles. So I'll do, you know, 2 of these, whatever. All right, let's go through this. Let's put some music. I don't know why the music stopped. Let's put some music. Where's my library? Library collections. Let's shuffle this. Is there a way to shuffle? No? Alright, whatever. Okay. So let's rephrase this. Actually, I'm gonna close this because I have a wider view in here. By the way, you know, people in Twitch, how often do you do Leetcode? If you do anything, I'm curious. What about you guys, YouTube guys? How often do you do Leetcode? What do you think about Leetcode? Do you like the interviews that ask you for Leetcode questions, or you rather something like practical? I'm curious about that. So meanwhile, I see some responses there. Let's rephrase this. Sometimes when I write this with words, it helps. I'll write it here. So essentially what I want to do is, let's go by steps. Step 1, go through each character until I find a matching one. Step 2, when I find a matching one, DFS onto neighbor one. Step 3, make sure that I can get the full word path. If get the full path, return true. Else, return false. Very Pythonic. Okay, so that's the gist. Now, within the DFS is like the detail. DFS. What do we want to check inside of the DFS? So we're going to be passing the board. We're going to pass in X, Y, an index, integer values, and then the word. Now we have I forget how you call this, but like the resolution case, or like when you know you finished base case. If we reach this point, we are done. Otherwise, we keep on going. Since we call this initially, we know that there's a matching word, so we increase the index. So if this is found, sorry, if we're not out of bounds, so this would be my upper bound, lower bound. This is my j-1 left bound. This is my right bound. Okay, so there goes 5 minutes. I'm just gonna take into account 5, not 25, because I've been doing this for a while already, and I want to get this done. Okay, so we got that. So if the upper bound is not, how do you say, exceeded, and the new index, right? So word index is equal to word ij, then we can go ahead and proceed with the DFS, and we do the same thing. Well, actually here I should return false, because if we reach this point, it means that we didn't find, there's no neighbors. No neighbors. And never reached base case. That would be my guess. I mean, not guess, but my like this makes more sense essentially. So let's run this, and I'll compile it. So I don't know if you guys want to see the make file. It's very simple. Like I just build, and then I execute with the flags if I put any flags. Which at this case I'm not gonna run it with flags, and I still get the same thing, U as U. But so this annoys me because we shouldn't be getting to the U. Also, this means that if we ever get to this point, then this is false, and then we just I guess return DFS. All right, we'll see. Yeah. All right, I'll take care of the other things later. But okay, so that's the gist. Right now, so we have, let's go to the main file. I'm going through the for loop. I get into the first U and US, so the S is right, but then I'm going back to U, which is wrong. I'm just gonna do this. IDX equals IDX plus 1. Alright, my 10 extra minutes are almost done. Well, there was no error. That's... It's probably not right, but there's no error, so better than nothing. So I want to copy... Let's copy this, so... Okay, let's go here. Okay. Okay, I can get rid of this. I can get rid of that. I can get rid of the print. Get rid of that. I like the comments, so I'm gonna leave the comments. Okay. Wow. I don't know. I don't know how like entertaining this may be. I don't know how much entertaining value this has. Like it's probably more entertaining seeing me develop an application than doing Leetcode. I don't know. Also, doing live Leetcode solutions are not as quote unquote pretty as the pre-recorded ones. So let me see from my submission. And okay, so I did it in TypeScript, so at least I'll have to translate what I did in TypeScript. So if okay, so I have something similar. So I'm not sad that I actually like have the similar answer here where like I pass a board, I, J, word, and 0. Okay, so I'm happy with that. So then my DFS was just like, whoa. Okay, my DFS was not exactly the best. Oof. What did I do here? When did I submit this? October 2022, so a year and who knows how long ago. Wow, it's been a while. Okay. No, I don't want to see the solution. I want to see my code that I had in C# too before. Interesting. If word length equals index, did I? Index? What? What? So apparently, in order to avoid, so I would like add a hash. So let's try to like translate this. Essentially, what I was doing, like I wasn't that lost, but so this I have it almost the same. So index, what I don't get though is why index would be worth dot length, which is, let's okay, before I just write without thinking. So this is just checking the bounds. What? So what happens here is that when I go through the, well, what I'm looking at, because it's been a while, but like essentially if I go through this and it doesn't match, it puts that, and then here it doesn't match, puts the pound, and so on and so forth. So then let's say that I'm here, it matches, so I still put this so I don't have to go back, and then I go here and then it matches, but I still put that so I don't have to go back. It's kind of like a way of making sure that you don't go back, kind of what was happening before. But yeah, I don't know. So that's one thing that's happening there. So essentially I had like board I j equal to that. I don't know, yeah. On type string constant. As a character. Oh, there you go. Anyway, I don't love how I solved this looks ugly. It's not bad though. Like on TypeScript, like I think there wasn't a way to make it like any cleaner. I'm happy that the idea was right, so I just had like this detail here. These are the bounds, so these are the upper, lower, left, right bounds. Yeah, and then I had a reset. So essentially what it's saying is that if one of these return true, right? Like if any of these like have a successful path, then return true. And then you know, if none of these are like within the stack returning true, then you just reset. You know, yeah, like the letter that you're looking at, set it equal to the word. I don't get why resetting. Okay, so I'm gonna check actually different answers. I'm not 100% happy with this. That's crazy I did that. Probably have something nicer. Nope, same thing. So same thing, I just did like I flipped it. Same thing. Okay, this is a little bit different. Or maybe I didn't see the other one, but essentially like if it doesn't match, return false. Uh, so I have that, return true. Like it makes sense to me, I don't know. The only thing that I don't understand is this reset that I seem to be doing all the time. So essentially, let's see what it's saying. Out of range. Okay, that's fine. So first of all, I just want to see if this works, and if it works, then we have to try to understand. So this is like the first thing that I have, and if this matches, then we return true. The second thing that I do is on my solution that I'm seeing right here. Board ij equal to hashtag, so that I mark it as like viewed already. But then I'm guessing that like since I'm changing the board in here and then I'm passing the board like mutated here, then it's gonna get a mutation of this of the board with like this hashtag. But then like if for any reason like this are not good, like, or these are not part of the proper path, then I just reset the board. ij word index. So that's like a reset in case these how do you call it, recursions are not part of the correct path. That's my guess. And then if none of these result in like something that we're looking for, then I would return false. But then the way I wrote it here is I have all these conditions like packed into an if statement, and then like if one of these are true, meaning if one of these recursions at some point return true, then I return true. These are if I'm like going over the limits, return false. I mean, I know that if I write this, I'm gonna get a rightful answer, a successful answer, but I want to see like a cleaner one. I don't love what I have on TypeScript. There must be a cleaner way. So let's see this guy. So same thing, he had the same if rs return true, he can just return true, return false. So same thing, that's good. Okay, so it's the same thing. Yeah, board equals, yeah. So if you're going over the, yeah, okay, whatever. If word position does not equal, return false. Okay. If length, that's what I thought. So this is true. Position. Okay, so then it's doing the same thing. See? So I guess in TypeScript what I had was right. Same thing. Okay. fuck it, I'll translate my, I rather do my solution than someone else's. So let's do that. So I mean, I'm happy that I was very close to the solution. I had a couple of details that I was missing, but I was almost there. So I'm pretty happy. Especially in an interview, if you're working with someone and they see that you're close to the solution but you're not there yet, they tend to help you. They say like, oh, by the way, so are you sure you want to return false? Just there. Where would you return false? And then I don't know if you get stuck. The interviewer would say like, oh, like would you return true if you go beyond the limits? And then you would say like, oh no, you got to return false if you go beyond the limits. It's like, okay, so like implement that. And most often from what I've gotten before, the interviews are like that. Like they if they see that you get the idea but you have like minor details to implement, they tend to steer you towards the right solution. Obviously, it does take in account like, oh, how much did this guy had to be helped? If there's a candidate that didn't require any help, then obviously that would be a stronger candidate. But in general, they also tend to be like, oh, how good can I work with this person? Is he like, can he talk about his thought process? Because like, even though, I don't know, I would value more somebody that is like talking through his thought process, but then like, if you get to the solution by talking to the interviewer, I think that's valuable. So I don't know. Yeah, I don't know. Maybe, hopefully, the interviewer that's going through this problem with like X or Y candidate, and if let's say you get stuck in this, but still get to solve it through a little bit of help, the interviewer may see past through that and say like, okay, this guy, he's good to work in a team. He talks about his like thought process, and I'm able to help him through his thought process. So yeah. So this is a little bit cumbersome, but essentially my solution, I saw it just in Golang, and my solution, I think it's a little bit cleaner, so I'll just like translate this to Golang, honestly. That's what I have. Damn, look at this. I swear, like Golang, you almost see like very similar ways of setting up code. It's just that Golang is faster, better types in my opinion. Yeah, we don't have like strong generic types, but still, I just rather Golang. Do Golang instead of TypeScript. But okay, let's do this. So the first thing which I was proud of is that I got this right. Now I don't know why it's worth length equal to this. If I set this to 0, and I also have this to 0, the only way that makes sense is that at some point, since if that you go like one step further, like one recursion further, and at that recursion further, so let's say that you go through all the, like you found all the words, and then you increment index, and then like that last increment, it's just like length is equal to index, and you return true, means that you went through all of the words. That's, yeah, that would be my thought process. So then I would do that. If we reach this point, we're done. Okay, so same thing. Return false if goes past bounds or word index does not equal board row column. Yeah. So if the current index, or if the current character that you're looking at does not match the board X and Y or I and J, then you return false. So what are the bounds? Essentially the bounds are here. So if that, or if that. Alright, so upper and lower bound. And then I actually have to flip it because this, you know, here I was accounted for valid. Now I want to account for non-valid. So if I is bigger than 0, no, that does not make sense. If I is less than 0 means that we went past the upper bound. If I is bigger, equal or bigger than length.worth means that we went past the lower bound. If this is less, or j is bigger than or equal than right bound. Or the last one, word index does not equal board I j. So if any of those are, you know, if any of those happen, then we return false. And I can do some Golang magic here. Probably like some may be pissed about this, but it is what it is. Yeah, that's, I don't love how that looks, but I don't know. Maybe better. Whatever. I'll leave it like that. All right. So now we mark it as like visited. So this visited. And now, so we have to change this. So essentially, if any of these return true, so if that or this or this, right? So if that or that or that are true, return true. And then here we just reset what did we say? Board I j is equal to word index. Reset for other recursions that are successful at the moment. Wait, didn't I cover all the returns? Oh, you gotta love TypeScript. Okay, so I have true there. Then I have Okay, I will peek at other answers just for this. Return false. So okay, I was almost on the right track. Okay, let's see if we can make this any neater. What? Okay. Let's close this. I don't know. Like, the thing is that even though this looks a little bit more bunched up, I think it's easier to read. And then I guess I can say the same for this. I don't know. Whatever. I'll get rid of the format print. Okay, that looks good to me. Let's get rid of this. Let's put some spaces. Just to make it a little bit more readable. Okay. So I'm gonna copy to my clipboard. And go to the top. I know that this has to be private. Ah, damn it. So case 3 passed. Case 2 and case 1 is not passing. Now I want to look at my solution, not this guy's solution. Return false, return false. Backtracking. Backtrack is the same as DFS essentially. Simple backtracking. Okay, so this is almost exactly the same. Return DFS results. Buell. I have, okay. I mean, it's kind of similar. What did I miss? There I have exactly the same. Lend board 0, yeah, or board. Ah, I'm missing this. I think that's the culprit. And we can even put this like here. Expected expression. Oh, equal. It's a character, it's a rune, it's not a string. There you go. So I'm just gonna copy this line. Okay, so here oh my god. Forgot to put it on the clipboard. There you go. Let's run it one more time. Same thing. What am I missing? I mean, I don't want to copy the answer. I want to get it. Okay, that's right. I'm covering also this. I'm covering also len board j, len board 0, I, len board 0, I, j, okay. And I also have this. So I'm adding the index +1 within the DFS, so I don't need to do this. Temp board I, why temp board I? Temp board I is, well, I can do this. Just reset with this. Position POS. So we have the board index. Yeah, okay, this is the same as index. Okay. I probably have a small typo. I don't know where. Where do I have a typo? Return true. Return false. I'm covering all the cases. Row column equals to that. Return false. Length word, return true. Unless I don't have to put this if, because that if is already been dealt with in the DFS. And then well, at some point that has to return true if there's a truthful value. Otherwise it returns false. I'm gonna do this, and if not, I'll change it one more time. So essentially get rid of that, get rid of that, get rid of that, get rid of that. And then if not, I'll do the if. Okay. And I know I believe this may have to be with the factor that there's a mix of return values with the recursion. So the other one did. Okay, so case 2 now passed. So there's one more case that I'm not accounted for. ABC, false. CU true. Okay. What am I not accounted for? Board I, board length, return false, return true, row, board length, row. So this is not even like there's no way like that. Those are my if statements. Really? Wow. Okay, I mean, so I'm not checking for column boundaries, or I'm not checking for that. This will not like return false. It's just like it won't check for that. I mean, this will happen because that at some point will make that this is, you know, this happens, that this is not true. So okay, let's try this. So I'm checking out column by column bounds, and I don't care for this because this and that is exactly the same. What else? Okay, visited. Now this is not upper bound, this is just DFS. I don't know, that looks horrible, but okay, whatever, let's run it. Damn it. Okay, so that is not right. Board line, board row column. Let's put some music. Damn, I've taken my time. Just like, I know that this will work, but I don't want to copy this solution. I want to like derive my own. So I want to avoid copying what this person has. I know that this check is almost exactly what I had. Yeah. See, almost exactly the same. Which is upper bound, left bound, lower bound, right bound, then that. And honestly, you can include this in here, so I don't know why he put it separately. And then this is what I had previously, and then I have the index plus plus. This unnecessary. You can just use word. Well, if you're doing index plus plus, then yeah, you have to do this, and then you can reset like that. Otherwise, if you pass the +1 here, you don't have to do this temp. But I'm like I have the exact same thing with different nuances, but like the only thing is this, and then instead of saying return true, I just say return res. And I have that, I have that, I have that. Damn it, I deleted my upper and lower bound stuff. Or j is bigger than 0, or j is bigger or equal than len dot board. Or board I j is equal to the pound sign, and I believe that's about it. And then this doesn't have that. Ah, that looks weird. All right, let's try that. Wait, I missed something. Word index len. rs equals if rs return true. Well, here you just return. Oh. Return the FS word error. Okay, don't delete the parentheses. Okay, out of range. -1. Where? Longworth. Here. Where am I effing up? Okay. I'm gonna go to sleep in 10 minutes because I have work to do, but let's see if we can get this done before I have to go. Line 33? Nope. Return res. Well, unexpected helper solution go. What? Ah. Oh, I'm not doing anything. Duh. There you go. Well, it compiled. $10 minutes. We got 10 minutes. 10 minutes. I know I have the answer on the left. I just don't want to copy paste it because then you're not understanding what you're doing. I want to write it. What could be more, how do you call it, productive is looking for something that looks similar to mine. This too obfuscated? Yeah, this is too unnecessary. Whoa, what is this? Oh, Ruby. Damn, that's a horrible answer. But hey, at least he's getting the answer. If this says, okay, return true, okay, that's more or less what I have. A map. What? That's crazy. Damn. That is weird. Okay. So this a closure. I don't like closures. Yeah, I'm not a big fan of closures. Yeah, no. And the first one, oh, that, I was looking at the first one, okay. I really hope that if I mean, I don't know, that's the same as whatever he's doing. Case 2 passed, okay, so back at square one. Twitch people and YouTube people, any questions? I don't know, anything you want to ask? I don't know, put it on the comment section. What do you think about graphs? You guys think it's fun? I don't know. What do you think? Alright, so we want to do OR because some of this may return false. That's why. So if some of these return true at least once, then, you know, we have a truthful value, and then we return rest. There you go. Return, you know, this would be true. We have to reset the board in case that, like, we still, you know, we go through an iteration or recursion, but we're stuck on a dead end. So that's why we reset. That makes sense. This also makes sense. Then I have index +1. So my only caveat, or the only thing that bothers me, is that I don't want to, like, you know, I can do that and then I can go through. Just don't want to do what he's doing, but essentially that I'm, you know, if I do this, I'm doing exactly what he's doing. Where then current or char is equal to, well, first I would put that up top. So I would put that there. But I don't think that's gonna make a difference. Yeah. Oh. What? Yeah. That's the same thing though. If that shouldn't like, I mean, I'm trying to see if that changes anything, but wow. Okay. You know, I know that if I copy paste this is gonna be right, which I'm not gonna do. That provides zero value. I'm gonna cut the stream here. The thing that does make sense is the following. And this will return true at some point if it returns true, right? So I'm just saying if this, meaning if this is truthful, then, you know, return this. Why we don't want to return false if it's false at some point, and this is the reason why. Because you may have a false value, but that doesn't mean that further down, like let's say for example, I'm gonna go to main. Damn it. I'm gonna go to main. So let's say that I'm looking for USB, and let's say that I have a U here, right? So here, you know, I don't find anything here. You know, I do this, that, and that. So I have a false, you know, I have a false scenario, right? So that doesn't mean that further down there's not a USB combination where it could be, you know, USB. So therefore you don't wanna just do return this. You just wanna make sure that if this is true, then return. Now I don't think that I have to assign it to a solution. I'm gonna do it just to cover my tracks, but I believe that it's the same thing to what I have. There you go. So if res, you know, return true. So I don't believe. Ooh, okay. Oh, I'm messing up parentheses. Yeah, that doesn't change anything. Okay. So there's something wrong. I have a typo, but then that makes sense. You know, I'm checking upper and lower bounds, left, right bounds. If this has been already visited, or if the current index does not match the current character, then there's no point on going forward. Then therefore we return false. Then this right here, honestly, I don't know. We could easily just like get rid of that, and then just pass word plus index plus 1 here. Ooh, or was I getting the wrong because I saw somewhere where I missed to get rid of the plus 1, and that does matter. No, okay. Never mind. Damn it. Okay, so yeah, but essentially that's the gist. I have a small typo, probably like a stupid detail that doesn't like allow me to get the right answer, but you know, it's almost similar to this, which is there's like a submitted answer, so I know for a fact that, you know, somewhere here like there's the right answer. So I'm gonna cut the stream off here. I don't know, this is my first Leetcode stream. You know, this is Leetcode. It takes long. I don't like copy pasting this because I don't like the way he formatted his question, and I want to understand exactly what goes behind. I understand everything of this code, so I'm happy with this. And yeah, I'm probably gonna try to do development and Leetcode because I know that Leetcode can be a little bit dense at times. But yeah. Hey, what's up, Jem? I'm about to finish the stream. Thank you for dropping by, and be on the next stream. See you guys later. Take it easy. Bye.